So here we are at another goodness of fit test, and they're telling us for this one that, let's see here. They're telling us that each category is equally likely. So what we're gonna do is we've got to find out how many numbers there are, and I haven't done that yet, so you're gonna have to wait while I walk through this. Let's see, so 5 plus 17 plus 13, I should be able to do this in my head. That's at 35 plus 22 is going to be 57, and 12 is 69. I believe, I'm hoping I'm right. I better double check with my calculator. Let's see, so 5, 17, 13, 22, and 12. Yes, 69. So then to get the expected frequency, we're going to take the 69 and divide it by 5, because there's 5 categories that are equally likely. So I'm going to divide 69 by 5. I got 13.8. So I'm going to type in 13.8 in each of these expected cells. Oops, 13.8. Then what we're going to do is do that same calculation we did in the last problem. You have to do this. You got to subtract these two numbers, square the result, divide by the 13.8. So where's my pen? I'll write that down for you in case some of you are taking notes. So I'm going to do 5 minus 13.8. I'm going to square that, and then I'm going to divide by the 13.8. So 5 minus 13.8, I'm going to hit equals. I got negative 8.8. And then I got to square that. I got 77.4. Then I have to divide by 13.8. And that gave me 5.6. Let's see, how many decimal places do they want? 3 decimal places? Okay, we'll give it a few more. 5.611. I'm going to go 59. Okay, then I'm going to do the same thing. I'm going to do 7. I won't write this one down. 17 minus 13.8. I hit equals. I got 3.2. I'm going to square it. I got 10.24. I'm going to divide by the 13.8. I got 0.742. Then it's 0, then 2, and then 8. So I'll try that. And then same deal, 13 minus 13.8. I got negative 0.8. Square it. I'm going to get 0.64. Divide by the 13.8. So I'm getting 0.04638. I'll go with. And then 22 minus 13.8. Got 8.2. I'm going to square it. 67.24 divided by 13.8. I got 4.872 I'll go with. What I do when I round for this, I mean, who knows if I'm going to get it right, but I try to go until when I round, I go to a decimal place where I won't have to round up. It doesn't always work, but I think it will here. Actually, know what I'm going to do? I'm going to go to 5, see if it'll accept that. Then the last one, 12 minus 13.8. I guess I can show you this on this calculator. Why don't I? I forgot I had this here. So 12, so I'm doing this last one right here. 12 minus 13.8. Oops, oh yeah, right. 12 minus 13.8 gave me that difference. That's the difference between those two. And then I'm going to square that. So in this calculator, they get that nice little x squared button. That's 3.24. Then I'm going to divide by the 13.8 expected. And that gave me that for a chi-square, for a squared piercing residual. 0.2348 I'll go with. Okay, so now I've got to find the sum of these numbers. Well, let's see. I am thinking that, well, I guess I'll just try adding these up and see if it'll take that answer. 5.61159 plus 0.742. A spreadsheet works really well for these kind of calculations. I don't know why I hit equals. Plus 0.04. Let's see. Whoops. 0.4638. Hopefully this is going to be enough decimal places to get this right. 4.8725 plus 0.2348. So if I calculated this right, I got a chi-square number of 11.507. Did I hit enter? I must have clicked submit. Oh. Well, at least I got all those numbers right. Well, while I'm at it, let's see if yeah, okay, so like that. One thing you want to be careful of with my open math, I mean, it's a little late in the course to have this discussion, but if you keep checking your answer when it's partially undone, sometimes the problem just crashes, and you have to do a new problem. So how many degrees of freedom for this test are there? Well, I'm counting 5 categories, and for the goodness of fit test, we subtract 1 from the number of categories, so there's 4 categories. So now we're going to do the p-value. Well, to get the p-value by hand, so, well, we don't want to do this by hand. There's tables. There's also applets. And let's see, I found an applet for us. Where was it? Let's see. Was it this one? Yeah, here we go. So I had 4 degrees of freedom. I don't remember how many, let's go back to that my open math thing. We had a test statistic of 11.507. So 11.507, and we do want to go above it. So it should give us, that's that test statistic. That's the p-value, 0.02142. Can I copy this? Let's see if it'll let me copy it. Control C. Where's my open math window? Let's see if it let me paste it. Oh, it did, but except I got to put the 0 in there. 0 point. Okay, so is that p-value less than the level of significance? Well, level of significance of 0.05. So they're saying any probability less than 0.05 means there's a, so we're going to do less than level of significance. So we're going to reject the null hypothesis. Now, one thing I didn't write here are the hypotheses. Maybe I should now before we get too far. So when you're doing these chi-square tests for association, it's not a bunch of symbols that you have to write. You really just are doing, you're going to say HO. Well, you know, there is no association, or there's no difference. There is, now remember, HO is always a statement of none. So there's no difference, no association between the categories. They're all equally likely. Tell you what, we'll just use ASS for an abbreviation. The null hypothesis, yeah, there's no difference. These categories are equally likely to happen. That's what we expected to get. And we came up with something, let's see, I should write HO. And H1, there is an association. Means they aren't equally likely to happen. So you're going to see this with, if you take a biology class, you'll see the chi-square test telling whether well, a set of genes or people following a set of genes or people or things or whatever, organisms. So we're going to reject the null hypothesis that says there is sufficient sample. Now this is where that flowchart comes in handy again. Let's see, there is sufficient evidence to warrant the rejection of the claim. That's a good chance. Let's see what the rest of them says. There's not sufficient evidence. No, we're gonna get rid of that one. The sample data supports claim that no, that's not true. There's not sufficient sample evidence to support the claim that, well, no. The only one that makes sense to me is this one. Let's see if I get it right. And I did. Okay. So that's the process of a chi-square test by hand. And I want you to do one of these by hand. You know, for the investigated task, it's just a one-way. It's just a one goodness fit. So and it's not that bad. Now, using a calculator though, I do want this to be a little bit long video. Let me clear all this, clear all drawing. If you come back to, let's see, somewhere here it is. Here's the test statistic. I mean, here's the online applet. To make this work, you do have to put in the observed. I think you got to put in the expected. I haven't done that yet this semester. Let's see. Let's move this over. So I honestly don't remember. We're going to be exploring this together. So I got 5 in category A. I got 17 in category B and 13 in category C. Not 14, 13. I got 22 in D and 12 in E. Let's see if it'll do the expected. No. Okay, so the expected frequency was 13.8. Thought there was a way to make this be equally likely. All right. So 13.8. The other thing, while I'm thinking about this, you have to make sure you have at least 5 in each category, right? Or else you can't run a goodness of fit test or a chi-square test at all. And yet what you do is you have to combine categories. Let's see if that'll calculate it for me. Let's see. 0.2 is expected proportion. They gave me that 11.5. So what this doesn't look like this applet will give us quite enough decimal places to make my open math happy. So we might have to do some looking for another. The p-value is okay. Degrees of freedom is 4. Yeah. So that's okay. Maybe we'll have to do some more looking, or you just do a goodness fit by hand. It's not that bad. Now, if you have a graphing calculator, while I'm at it, I might as well show you that. So so turn it on your calculator, stat, edit. Okay, you're gonna put your observed in L1. Now, this doesn't work for an 83. If you have a TI 83, it will not calculate this. You need an 84 or better. So 13, 22, and 12. And then you come over to L2. And you got to type in your 13.8 in each cell. And then what you do is once you get your observed in L1, you're expecting L2. It doesn't matter what list you put them on, but that's what I have them on. Then you press stat, test, and I hit the up arrow to get down there faster. Chi-square GOF, goodness of fit test. And it's going to ask you, where do you have your observed? Where do you have your expected? How many degrees of freedom do you have? Well, we have 4. If we calculate it, that gives us the same values. Okay, so that's the graphing calculator is nice, but as you can see, it's not all that much faster. So I hope that helps you solve this question.